All right, kids, we're working in pre-calc here, looking at inverse relations and functions. So first thing is, if we have an ordered pair and it has AB, that's part of the relation, then its inverse is going to be BA. Right? That means they just did a little quick flipperoo right there, no big deal. Okay, so if we had 1, 2, 3, 5, 6, 4, right, what are we going to have on the inverse? 2, 1, 5, 3, 4, 6. All right, so that's all we need to do with it. Okay, consider the line y equals 2x. What's the table of value look like? Now switch the xy's. What's the line look like now? Okay, so let's start with what does it look like? Then we'll make a table. Sorry, my nose got itchy there. All right, so we got 0, 0, right? Plug in 1, right? We're going to get 2. Plug in 2, we get 4. How about negative 1? We get negative 2. So let's take a look here. 0, 0. All right, so we get this line just like that. All right, now let's flip-flop them. So here we go. We're going to work with the inverse. So negative 2 gets negative 1, 0 gets 0, 2 gets 1, and 4 gets 2. So this is our new function. And we'll just blindly plot some points here. So negative 2, we get 1, 2, we get positive 1. And what's the other one now? 4 gets 2. All right, so it's still a linear function. We can see what's going on here. We just had to flip them around. Okay, so that's what's going to happen. So in summary, when we look at graphing these, if we put a diagonal line, y equals 1x plus 0, we need the whole thing. So what should happen is if I were to put this line in here, we're going to see that this line has flipped itself around. Okay. So it now has a reflection around y equals x. So our identity function. Okay. So, I mean, that's going to happen. We are dealing with, at first, a function, but the inverse itself may not be a function. So we're going to have a couple ways to test that. And what we do is we're going to think about the vertical line test. That's what we typically have done, right? It hits once and only once. But if I want to know if its inverse is a function, I'm going to use the horizontal line test. Okay, so that means I'm going to go left to right. And it's the same premise. If it hits once and only once, then it's okay. So that means if I go horizontally like this, and it hits once and only once, that means I don't really have to do, if the question is only about whether it's still a function, I don't have to actually make the second graph that we did here on the right. All they really need to do is do the horizontal test. If it hits once and only once, we're good. Now that I already have the function graphed here, I can do the vertical line test and say, okay, yeah, so do I actually need the horizontal line test? Not for this problem, but let's take a look at these. So we're going to go through, just remember the vertical line test. So first thing is we're going to say yes, no, yes, no. Yeah, that works. All right, and now what we'll do is we'll go through and we'll identify based on the horizontal line test whose inverse is a function. No. Yes. 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 And if we put this one on here, we get a no. All right, so anything that has a double yes, that's said to be 1-to-1. So if it passes the vertical and horizontal line test, then we're in good shape. So what was that? We had this one in here. Okay, and that was it. Okay. So 1-to-1 vocabulary. All right, how do we do this? Those were all graphs and tables and stuff like that. But what are we actually going to do? Here's what we're going to do. We're going to use f of x. Remember, that's the same thing as y. We're going to change out the x and the y. We're going to solve for y. And then we're going to say it's not f of x anymore. It's f to the negative first power and then times x. Okay, so it means this is y, 2x plus 5. Hopefully you remember doing this in Algebra 2. X equals 2y plus 5. We're going to solve for y. So first thing was just flip-flop the x and the y. It doesn't matter what's with it. Just keep it that way. So we're going to subtract 5. And we're going to divide by 2. Okay, that gives me y. So now I want to say the inverse of f of x is x minus 5 all over 2. We can make into a complex fraction if we need to match a multiple choice, but sincerely, that's all I need to see at that point. Okay, so remember this is y. So I'm going to say x equals 5y squared. We're going to divide by 5. We'll get rid of that first. So now I have y squared equals x over 5. How do we get rid of that square? You can take the square root. Right? And that's going to cover everything because it was the last thing we did. So this would be y. So I'm going to go ahead and just write it as g to the negative first power. That means the inverse of g is the square root of x over 5. And we know we could write this with a 1/2 power if we need to do anything with that. So those should be inverses. Now, if I really want to check with either of these, what I can do is just make a table, right? 0, 1. Maybe put a 2 in here. So if I use the original 0 squared, I'm going to get 0. If I put 1 in, 1 squared is 1, I get 5. 2 is 4, so I get 20. So that means in this table, 0, 5, 20 as the x value has to turn into 0, 1, 2. So 0 divided by 5 is 0, square root is 0. 5 divided by 5 is 1, square root of 1 is 1. And 20 divided by 5 is 4, square root of 4 is 2. So it does work out just working with our tables. So you have a way to check. It's not just, hey, Mr. Tullis said do this, and then all of a sudden it works. Okay, so you can always make a table to check. But here's the deal. Since we're in pre-calc, even in Algebra 2, we stopped using that test. What we do is we do a composition. So I'm going to take f of x, right? I'm going to take g of x and put it inside of f of x. And I also have to be able to put f of x into g of x. So instead of making tables, we need to make sure they pass the test both ways. So it doesn't matter which way I start with. So I'm going to take this. I'm going to use like substitution, put it right here. 3 times x plus 6 over 3 minus 6. Well, what's going to happen to my 3 divided by 3? They cancel out. So I have x plus 6 minus 6. I dropped the parentheses at this point because I only had them in there to show the multiplication and the substitution. Since I couldn't do anything else with x plus 6, now we're going to work outside of it. So positive 6 and negative 6, they cancel out, so you get plain old x. So it works one way, but remember, I do have to check both ways. So now I'm going to take my 3x minus 6 and put it in right here. 3x minus 6, again, using parentheses to show my substitution. So let's see what happens. All right, so now these parentheses are kind of pointless, right? There's nothing else we can do in there. So negative 6 plus 6, that's 0. And if I have 3x divided by 3, that's just x. So it does pass both ways, that they both turn into plain old x, which means these are, yes, truly inverses. All right, let's check out the other one. Let's see, we're going to take this whole thing and put it right here. So 1 plus 2 times x plus 1 over 2. All right, so 2, we're going to divide out the 2, so that's gone. I got 1 plus x plus 1. So I have x plus 2, which is not x, right? So we say wah, wah, wah. No, these are not inverses. Now here's the upside is I don't have to test the other half of it. So don't be too upset that it just didn't work out. But if it did, remember, I would have to go back and plug this whole thing in for that x. So 1 plus 2x plus 1 all over 2. Right, and we notice again, what happens is I'm going to get 2x plus 2 over 2, and we can reduce the whole thing, so I get x plus 1. Okay, so notice even the composition doesn't give me the same thing. Okay, but if you would have worked the other side of it first, oh my goodness, if you would have worked the other side of it first, you would have been okay as well. All right, we have a couple problems to try here. Make sure you check the numbers as you go. If you have any questions or concerns, we'll talk about it in class.